So today we're going to start using the distributive property in a different way, and we're going to use it to factor. And so what we're doing is we're going to factor, which means we're going to undo that distributive property. And so just like when you learned how to add, you learned how to subtract afterwards so you could undo addition. And then when you learned how to multiply, you learned how to divide so we could undo it. And so now when you learn how to undo all this multiplication, we've learned how to do. So today is the first of a few lessons to teach us how do we switch between the two. So going ahead to get us started, let's learn what the greatest common factor between terms is so that we can later use that to actually factor. You're not going to have homework steps saying go find the GCF. They're just going to tell you to go ahead and factor, but to learn how to factor we need to find the GCF of a polynomial. So to start with, what we're going to do is I'm going to write the prime factorization of each term. So prime means it's the small, I'm writing out all the factors that I could use in their simplest form. So what are two numbers I multiply to get 4? Well, that's 2 times 2. And I wanted to use 2 times 2 and not 4 times 1 because 4 is not a prime number because it has factors that are not 1 and itself. 2, on the other hand, its only factors that multiply to 2 are 1 and 2, so it's prime. So that's why we want to use 2 times 2 instead of 4. And so with my x's, I want to write them out individually, so x cubed represents 3 x's multiplied together. So we're going to do the same thing for 12. We'll pick two numbers you use to multiply to 12. So you can use 2 and 6. And then I have 2 x's. But is 6 a prime number? Does it have only factors of 1 and itself? No. So because of that, we can't keep 6. I need to replace it with 2 times 3, which are prime factors. So if you're using a factor that's not prime, you can still use it to break it down into smaller factors. So let's go work on 8. So 8 is the same thing as 2 times 4, and then I have an x. But 2 is prime, 4 is not, because we already talked about that at the beginning. So instead of having 4, we're going to erase it and write 2 times 2. So the whole idea for common factors is, does it happen for each term in the polynomial? So in this case, I'm going to circle the ones that they share. So they all share 1, 2. They all actually share a second 2. And then I can only circle 1x that they all share. They don't all share more than 1. So my GCF is 2 times x. But I want to write this in simplest form. And so in simplest form, that's going to be 4x. We're going to use these GCFs to factor in a minute or two. So that's what our focus is right now, is what is my GCF? So let's go and look at another example. So I have 4b cubed negative 12b squared and negative 6b. So I can write 4b cubed as 2 times 3b's this time. And then negative 12 can be written as negative 3 times 4 times b times b. And then can I leave that 4? No, we cannot. I have to switch 4 out for 2 times 2. So be on the lookout for things that are not prime. We never know when they're going to show up. So with that, negative 6 would be negative 3 times 2 times b. So what do they all share this time? In this case, I see I have 1, 2 they all share, and I see 1b they all share. So my GCF is 2 times b which is just 2b. So if you circled it in all of them, you only write it down once. So be careful with that. So I want you to go and try this one for me. And so I'm going to write the final answer on the board. So go ahead and pause so you can work it out on your own. Okay. So you should have gotten 3t squared. So what our hope is moving forward is that we don't have to write that table out every time. Oops. Because that can take a lot away from us, and we don't want that to happen. So with that, let's go ahead and go look at what does it mean to factor out a monomial. So we want to first identify what is my GCF. Okay. So what is my greatest common factor between these three terms? So I have a 3, a 12, and a 15. So what's the biggest number that they all share factor-wise? Well, 3 goes into 3, and it goes into 12, and it goes into 15. And so there's nothing bigger since I'm using that number 3, because 3's factors are only 3 and 1. And so how many x's do they all share? In this case, it is just 1x, because I will use the smallest number of x's for my GCF. So when it's my GCF, what we're going to do is I'm going to write it, my 3 terms, I'm going to write 3x and then a set of parentheses for each term. I'm still going to use the same signs in between them. So I'll have minus 3x and use parentheses, and I would have plus 3x and then parentheses. So this next part is what's left over when I pull that 3x away. What was there to start with before I distributed this 3x? So in this case, what is 3 divided by the 3 over here? Well, that's 1. And then I took away 1x from this x cubed, which leaves me with an x squared. Same thing for 12. What is 12 divided by 3? Well, that's going to be 4. And I had x squared, but I took away one of those x's, so I just have 1 left over. And last but not least, what is 15 divided by 3? Well, that's 5. And I only had 1x up here, and I used my 1x, so it's just 5 in that set of parentheses. So now that I have my GCF written out in all my other terms, and I wrote them all as products, what we're going to do is I'm going to take that 3x away. So I want to pull it out front of everything. So what needs to go in parentheses beside it? Well, it's what's in red and the signs. I actually need to undo one of those circles because it was too big when I circled it. I circled some signs and that was going to be confusing. And so we factor all of those out. They all go out front together. And so I'm left with just 1x squared is the same thing as x squared. And then I'll keep my sign. And then I'm going to bring down my 4x. And then I'm going to keep my sign. And I'll bring down my 5. So I've now factored out my first polynomial factoring out just its GCF as a monomial. So here are those steps written out in order. So first off, you need to identify what is my GCF. And then we'll write each term as a product of the GCF and the other factors that were in that problem. And then you will factor out the GCF. So those are your 3 steps. If you need a moment to write these down in your notes, hit pause. I'm going to go ahead and move on to our next example if you don't hit pause. So, moving on, we have 8x squared minus 12x. So, first things first, I need to find my GCF. My GCF in this case, well, so 8 has the factors 1, 2, 4, and 8. 12 has factors of 1, 2, 3, 4, 6, and 12. The biggest number that I listed twice is 4. Then I have an x squared and an x, and I can only pull out the smallest number, so that's just going to be a 4x. So this will leave me, I have two terms, so I need to write 4x parentheses, keep the sign, 4x parentheses. So when I go to fill it in, 8 divided by 4 is 2. I had x squared, but I only have 1 down here, so I need to keep an x. And then 12 divided by 4 is 3. And then I used my only x, so it's just a 3. So when I factor that 4x out, we'll have in parentheses, well, I'm going to have two terms. I'm going to have a minus in between them because I'm going to keep that sign. And I have 2x up front and a 3 in the back. So let's do another one. So first off, let's find my GCF. My GCF in this case is 6. I don't have enough m's to pull out from everybody, so it's just 6. So sometimes you don't get to have a variable. So I'm going to have 6 parentheses minus 6 parentheses minus 6 parentheses. So 6 divided by 6 is 1. And then I'm going to have an m cubed because I didn't take any m's out. And then 12 divided by 6 is 2. I didn't take any m's out, so I'll have an m squared. And then 24, that 6 at the end looks like a b. I'm going to make that look more like a 6. So 24 divided by 6 is 4. So when I go to factor my 6 out, I'll have my m cubed minus 2m squared minus 4. Okay, so let's go and work out another problem. We also need to talk about how do we solve equations that are already factored for us. You're going to have a few of these in your homework assignment. And so when the problem has already been factored, all we have to do is, how do I get to 0? So first thing I need to check out is it equal to 0? If it's not, we're going to have to do something else. So all of your problems in your homework are already set equal to 0, and that's because of the type we're working with until we have some few more processes for us. So with this one, it is set equal to 0, and I need to see what factors do I have. So in this case, I have 3 separate factors. So what we're looking for is what multiplies to 0. Well, the only thing that I can use to get to multiply to 0 is one of those pieces has to be 0. So because of that, we're going to set each factor individually equal to 0. So that's going to give me x equals 0, x plus 2 equals 0, x plus 7 equals 0. So I have 3 factors, so I'm going to have 3 answers. Well, that first equation is already solved for. I can't solve anything because I don't have anything to move. So one of my answers will be x could equal 0. So for x plus 2, I need to solve for x. So since x is added with 2, I will subtract 2 to solve for x, and I get x equals negative 2. So that will be my second possible answer. Since I had 3 factors, I'll have 3 answers. Last but not least, I have x plus 7, so I will need to subtract 7 from both sides. And so 0 minus 7 is negative 7, and I'm left with x over here. So that will give me, my third answer. But I need to write all of them in one spot. So I have x equals 0, x equals negative 2, and x equals negative 7. And then we will box all of those. As a reminder, your book tends to write them in set notation. So instead of writing those 3 out that way, it would say my answer is bracket negative 7, negative 2, 0, because it's going to put them in numerical order. Negative 7 is the smallest. And so that's another way to write out my answer as a set of 3 answers. So here are your steps. First thing, make sure the equation is set equal to 0. We'll see why that's such a big important step in the next couple lessons, even though today's are already set equal to 0. Then our next step will be set each factor equal to 0. So set each thing that is multiplied together separately equal to 0. And then we will solve each equation separately. And then because each factor will give me part of my solution, we need to write all of my answers together at the very end. So if you need another moment with these steps, hit pause. I'm going to go ahead and go do another example. So just because of some things that are coming up, I'm going to change this problem a little bit. So first off, I'm going to create a little spot so I can go in. I'm going to make this a 2x. Okay, so now we're going to solve this problem. So I am set equal to 0, so I'm good to go. So I have 2 separate factors. So I'm going to have 2 equations and 2 answers this time. So I'll have 2x minus 4 equals 0 and x plus 9 equals 0. I can do this again because the only way for me to multiply 2 things together to get 0 is one of them has to be 0. There's no other number I can multiply by and get a 0. So solving my x plus 9, I will subtract 9, just like we did in our other problems, which will leave me with x equals negative 9. And then in my other equation, my 2x minus 4, well, first thing I have to do to solve for x is get rid of this 4. So in this case, I need to add 4 because it's subtracted. So I have 2x equals positive 4. Then, to solve for x, I need to divide by 2. So I have x equals 2. So my answers, you could write it as x equals 2 and x equals negative 9, and box that as my answer. Oops, it ran into my negative 9. Or you could write your answer as a set and write negative 9, 2, because we want to write the smaller number first. So those are the 2 ways that you can write your answers with these. Questions, comments, concerns? Let me know if you have them. And so now you'll go online onto Moodle and do your homework assignment. Let me know if you have questions. I am available to help you.